Udo Games olarak düzenlediğimiz NexGenDev'e hepiniz tekrar hoş geldiniz. Bugünkü etkinliğimizde optimizasyon ipuçları hakkında bilgi alacağız. Bununla ilgili de Unity Developer Thomas bizimle olacak. Welcome to NexGenDev Developer Forum. Today we are talking about optimization tips and tricks. Quick tips and tricks. In this segmentation, our guest Thomas Winkley will talk about a few tips on using Unity's profile and a few optimization tricks you can use while you develop your games. And let's know Tom first. Okay, Tom.
Hey, hi everybody. Happy Tuesday, I guess evening for a lot of you, morning for me. Yeah, I'm here to talk about some tips and tricks and just kind of give you an overview of what I do and that kind of stuff. A little disclaimer first. So I write code and I teach. I am definitely not what I would consider an optimization expert, but I can definitely share with you tips, tricks, things I've done, and also give you a lot of information to research. And also, while we're talking, please don't disparage pizza. It's the best food ever made, and I can't tolerate it. It's the best. So, a little bit about me. So I am the live content producer at Unity. I'm also a Unity certified instructor. There's some of my social media stuff, but I spend a lot of my time teaching and of course developing some of my own apps in my free time. Then outside of that, I play a lot of competitive fighting games and like to travel here and there, when the airports are open and the world is normal. So the big thing I want to talk about kind of in this presentation is optimization should start when you start building your game. It is so much easier to go look at the profiler when you're ready to publish and make micro adjustments and small changes than it is to realize you have a huge performance problem right when you're ready to launch or when you're close to completing development, and then realize you have to go back and start going through these big iterative processes to overhaul the performance of it. So really, when you're building a project, I just want to make it clear that in all the research I've been doing and all this, anything I've ever looked at, that's the big key is you should be thinking optimally about your project from the jump, and you should know the platform you're building for, and you should know kind of the requirements you need to meet in order to make that work. Whether it's a virtual reality application, augmented reality, whether you're building something for mobile or high-end PC, that's really going to set kind of the directive of what you need to look for and help with your decision making. So just wanted to make sure I get that message kind of shared out there to let you know. So the first thing I want to talk about a little bit is optimizing for graphics. Again, not a graphics engineer, just a programmer, but there's a lot of really good tips and tricks, things you can find through Unity's documentation and a bunch of other websites, and I will share all of that out there to you all as well through links. So the first thing is draw call batching. This is something Unity actually does for you, but there are some gotchas that kind of go along with draw call batching that you're going to want to consider as you're working on your Unity project. So the biggest one that I saw as I was looking through kind of how draw call batching works and what Unity considers is a couple of things. So first of all, it has dynamic batching for small meshes, and this is actually going to transform the vertices using the CPU, and it's going to group a bunch of similar vertices together and then draw them all in one go. I hope y'all can hear my dogs. That's Joe and Penny. They like to come into presentations as much as possible and hang out. So. The other thing is, looking at static batching. So this combines static or non-moving meshes into big meshes, and it renders them in a faster, in a much faster way. But there's a couple rules that apply to batching. So first of all, they have to share a material. They cannot have a unique material in order to be batched. So this is important when we start thinking about accessing materials through code as well. So if you use renderer.material, you're actually creating a copy of that material's instance and modifying that. So it's really important when you're accessing through code that you use render.sharedMaterial, because that will modify the material that all of these objects are sharing. And it's also important to note that if you want to do a bunch of batching work and have it picked up in Unity, you need to have shared instances of materials for that to work. If you want to jump in and look at other documentation, docs.unity.3d, their manual, they have a draw call batching segment you can read through with a ton of information. It's also worth noting that game objects won't be batched if they contain mirroring on the transform. So, for example, if you have a scale of, say, 1 and a scale of -1, those objects will not be batched together. So you have to consider that too, that if they're exact opposites, that can cause some problems with batching. So this is one that actually kind of caught me off guard and I wasn't aware of, and it got shared to me by a couple internal folks at Unity, and it's just something like you don't think about until you have to, but you want to think about optimizing your UI in Unity. So Unity, the way it does UI is it converts it into a mesh and then draws it. And so every time your UI updates, it's redrawing that entire mesh. So a best practice here would be to organize your UI with your static and your dynamic components so that any components that are updating regularly are in their own group and you're only redrawing those specific pieces and not the things that aren't changing. So that way you're not, worried about constantly moving these. I would also argue that a really good optimization tip, and we'll talk about this in code 2 down the road, is that instead of it's very common, specifically when you're prototyping, and especially I think when you're like an intermediate developer or maybe a little more advanced beginner, you generally just want to have it's very common habit to use the update method to update data inside of your UI, right? Where it's like, hey, I just need to get this game score updated, so I'll just put, this update inside the update call, and it'll just check the game score variable every frame, and if it ever changes, then it'll immediately update. But basically at that point, you're doing a check every frame, and if it changes, it's looking at it differently. So using events and stuff can be better for that. But again, the biggest point here is make sure that if you have a ton of UI components, if your game is built completely in UI, this would be very helpful as well. But, if it's not updating constantly, separate it out and have 2 different groupings so that you're only worrying about the stuff that is updating dynamically being redrawn when it needs to. All right. This is an obvious one. I think a lot of people that have been working in game dev a long time are going to look at this and go, duh, but I just want to make sure it gets out there and gets shared, right? You want to reduce your poly count. You want to keep the triangle count low if possible. More triangles equals more rendering equals lower performance. And of course, it also depends on what your project is, which is why defining your project early is super important. If your game is a super high resolution, beautiful world that is meant to run on high-end machines, you might not want to reduce your poly count, right? Now, you might want to optimize it so that you're not using stuff extraneously, but you still want to make sure, it fits your need. However, if you're making, say, a Minecraft clone, probably a lot of room for optimization there, right? It really depends on what you're building, but this is a thing to consider, what's your poly budget? And again, depending on your platform, this can change and shift. This is another tip that, again, it's kind of a no-brainer if you've been in the industry for a while, but if you haven't had to optimize or had to worry about it, this is a big one. You should bake your lighting whenever possible. Real-time lighting is expensive, albeit beautiful, but if you can bake it, you should. You should bake cookies, you should bake brownies, you should bake cakes, but you should also definitely bake lighting. Make sure you get that stuff cooked if you can. And we'll kind of see an example of that through the 3D game kit examples here for Unity. But again, if you can bake it, do it. If you don't need it to update dynamically, why worry about it? Use the Frame Debugger. So Unity has this really cool graphics tool called the Frame Debugger. I won't demonstrate it today because I'll be honest, I'm not an expert at it, and I would feel silly trying to just fudge around with it and make y'all just watch me kind of fiddle around. But you can actually use the Frame Debugger to show draw call information, and you can control the playback of the frame as it builds and look through and see how things are being drawn and rendered and actually look at each individual draw piece. And this is really useful specifically for stuff that could be being drawn that isn't seen by the player, right? So you can actually go through, and there's a really good Learn project by Cristiano, who's an Oculus developer, talking about optimization for virtual reality that goes into more depth with this. But you can literally look at this and see oh, this object is being completely occluded by a building, or it's inside of a building, but for some reason it's being drawn, right? That's a waste of draw calls that you can use this frame by frame or this frame debugger to go and look into and help really get your occlusion culling a little stronger and a little better. So something to consider and look at as well is using that tool.
Thomas, do you have the link or the name of the?
Yes, actually.
Can you please share it with us?
Absolutely. Yep. So there's a couple links I want to share actually in the chat. So I'll drop this in Twitch chat. And then I'll also drop this in the Zoom chat. So there's
That's
the
great.
just introduction to using Unity's profiler. And then here actually is the documentation on the profiler. This goes a lot more in depth than I'm going to go today on how to use the profiler, but it talks about all the different modes you have available, all the different data and the things you can use. Oh, interesting. It's not letting me share both my items. All right. And then the other thing I want to show is actually off of Unity Learn. Let me see here. I'm going to grab it off Learn really quick because this is a super, really good one. And this was actually, this course was produced in tangent with Oculus. And the only downside to it I can say is that because of the time it takes to make really high-end courses like this, I think it only works with like specific versions of Unity for some of the build stuff, like the vertical slice and some of the code. But the optimization tips and information is absolutely invaluable. And Cristiano at Oculus is a virtual reality debugging and profiling wizard. So a really, really good person to learn from and super, super smart. So I would definitely recommend checking that out. And they'll talk about the frame debugger and different tips and how you can use the profiler in depth here. Okay, so that is the long and quick run of what you can do for graphics optimization. Again, there's so much more you can do as well, right? Unity does have, different scriptable render pipelines you can access. And you can, of course, use the high definition render pipeline if you're aiming to target really high end stuff. And of course, you have like the standard render pipeline and then the lightweight render pipeline, which is now the universal render pipeline. So yeah, then you have the universal render pipeline, which is really about optimization from the jump, where you can build out customized profiles and things like that. I would also definitely recommend hitting learn.unity.com, and you can research some stuff on the universal render pipelines as well and get a lot of really good information on how to manage and use those to help optimize stuff. So let's talk about optimizing code. Again, some of y'all in here are going to be longtime veterans of software development, and you're like, duh, Tom, we know this. It's obvious. That's fine. It's always good in my mind to kind of remember and remind yourself of the stuff you do, right? And maybe even the stuff you just do naturally that you don't consider. So the first big thing is object pooling. It's obvious. It's simple. It's simple if you've done it before. It's easy, but it avoids large amounts of instantiation. It also avoids garbage collection when you're destroying tons of objects, right? Because you can keep the same batch of objects in and just turn them off and on as you need them. This, of course, is really good for bullets, any objects that spawn in mass. It's always really helpful, right, to help improve your performance. Unless you're using dots, in which case, then you can, do a lot of really, really fun stuff. Dots, of course, if you're looking for maximum ultimate performance, Unity does have the data-oriented tech stack, which is in, I still think, beta. But definitely, if you want ultimate performance and ultimate memory organization and control, dots is your friend, and you should use it. If you are an intermediate programmer like myself, it's going to be a little harder on you, but you can definitely do it. It's just maybe going to take you a little more time. The other big option, cache as much as you can, right? I say cache everything, but you don't have to cache everything, but it helps. It helps to have a reference to it already and not having to go search down that reference whenever you want to use something. Avoid using GameObject.find. This is a big thing that gets like beginners and intermediate programmers, right? This searches the entire hierarchy whenever you call it. So if you jump in and say, hey, like, find me the game manager, or find me this component on this object or whatever, it's going to search the whole hierarchy. So depending on the number of objects in your hierarchy, that's a big ask. So yeah, it's just better to cache them during load, maybe behind a loading screen, and then you have a reference to them as needed if you do need to use GameObject.find, right? Do it during awake, do it during start, have a loading screen or something that's covering up the loading stuff, and then you can kind of go from there if you do need to do big lifts and big loads. How are we doing on time? Let me check the clock. Okay, we're doing all right. So this one is interesting. It's remove debugs, right? And again, this is a scale thing. It can be really expensive if you do it incessantly, like I do. Whenever I'm debugging something, trying to figure out why something's not working, I just start throwing debug.logs all over the place. And again, this is a command. This is a call that you're making. So if you've got that in a bunch of different methods, all in update, for example, and it's calling every frame, like your scale is getting really big, really massive. So make sure to go through and clean those out if you use them. And keep yourself honest on those. Or if you don't need them, don't use them, right? Use them sparingly. And again, it's really only an issue if you're calling it a lot. It's an issue of scale, but it definitely is something that can affect your performance. So keep an eye out for that. Using coroutines over updates is a big one, I think. And honestly, I think that's kind of a transition piece, right? That's something that for me at one point, realizing I could start doing that and moving to coroutines where I could control the timing of the code without having to do a check every frame, without having to think every single frame like, oh, maybe this will work here. You can just use a coroutine. If the condition's met, fire off the coroutine, it runs the thing, and then you can tell it to break away or to stop, and you're not constantly checking and running these varying methods. It's just a lot better than having everything updating and update. I also really love the idea of using delegates and events, right? Another thing you can do, instead of, like we were talking about the UI earlier, instead of having a score that is checking and update every frame if the score has changed and just updating every single frame, you can just have a score update event that fires and then modifies the UI at that point, or modifies whatever else needs to be changed just at that point. So that call happens, completes, and then it waits again until that event is needed again, right? That to me is it's an optimal way to code it. I also think it looks a lot cleaner than digging through a whole bunch of updates. So it helps make your code more modular, more readable too. So if people are trying to code through it later, it's helpful, it's friendly. So again, coroutines over update, events over just putting everything in update, fire off those events when stuff needs to change. It'll make life a little easier. And then, of course, the thing we're here to talk about a little bit more is use Unity's profiler to help find performance drains. This is where you're going to dig into your different frame rendering pieces or your different commands and find out what's going on and where the big lifts are. As you can see from the screenshot, obviously rendering is doing almost all of the work, right? Draw calls are expensive, rendering is expensive. So that's where most of our utilization is. And you can see by the graph here, rendering is the green, which is this area here. And then from there, we have like our scripts in the blue. We have some physics stuff down here. And again, this is a specific image from the profiling, the 3D game kit. So this isn't code I've written. This is their project tutorial. I just wanted to pull up, run the profiler on and take a look at. So the thing about the profiler is it's not going to tell you exactly where your issues are, but it's going to get you close, right? If you are trying to reduce draw calls and rendering and you need to be running at, say, 60 frames a second, we can look at this image right here and see that at this frame, which we can then highlight, we spiked in our draw calls and we were below, we were definitely not running at 60 frames per second. Looks like we were actually closer to, almost like 35, 40 frames a second. And you can actually see that inside the profiler here. And then we can actually go into this frame and we can look at the main thread and the render threads and all the different pieces and see all the different stuff happening. So a lot of stuff like that can be hit and brought out. The other thing that I actually learned this morning while researching for this talk was Unity has like a real-time stats tool, which I haven't seen before. And this is really helpful because you can just turn this on in play mode and you can actually just have your audio levels, your graphics, your main thread render time, just how many batches are there, your tries, your verts, and it just gives you this data in real time. So if you see the game starting to slow down as you're running through, you can actually just look over and see all those pieces and all that stuff, which is super helpful. Once you found where your issues might lie, you're going to go through and apply optimizations, and then you're going to actually run through that part of the level again. You're going to reprofile it, and then you're going to see if it improved your performance. It's definitely iterative, right? It's going to be, hey, I'm going to make these optimizations, see how that helped us, see what that did to our performance, see what my gains are, and then you can go reprofile it again to find other stuff you can fix and work on. I think, and this is a mistake I made and honestly still make, is, when I was still learning Unity and trying to figure it out and people would talk about the profiler and optimization, I kind of painted it in my mind as this tool that just tells me how to fix stuff and I immediately go fix it, right? But this is actually a tool to give you direction to then find things you can fix and change and modify. There are also a lot of cool things where you can export the data and you can use that data in external analytics tools and things like that. And there's also a lot of really nice analytics suites you can use through Unity extensions as well. I didn't look into too many of them, but I've definitely talked to other developers about those too.
Thomas, I would like to ask a question about that. Do we need a pro or professional plus subscription for that? No, we don't need that.
Yep, all the Unity tools are included with the which is the free license. So yeah, this just comes as part of the engine. And with that, let me actually show you, because I think my next slide is, all right, let's define something before we go in, because this is something I had to research a little bit. So Unity has a low-level player loop, and that's basically where it stores all of the scripts and code running your game. And the reason they do this is they actually separate it out between the player loop and the editor loop. And the editor loop is all the stuff impacting performance. It's actually the Unity editor itself that's coming up in the profiler. So they actually separate that out so you can see the two different pieces. So I just wanted to call that out before we look at the profiler. And so, yeah, just to be clear, your code contributes to the player loop's performance. It's your code. I did look into this. You can totally write your own low-level player loop. I cannot do that, but you could probably do it. Like, I've never written a low-level player loop before. It's totally possible. It's in the documentation. Yeah.
I don't know how to do that, but you say it's possible, right?
It is possible. I was reading through the forums and reading through the documentation. It's a thing that can be done. It is not a thing I have attempted. So
I would like to hear from guys if anybody had tried something like that before. That would be awesome. Yeah.
So with that, let me see if I can alt tab over to Unity. All right. Am I still sharing the Unity screen, or am I sharing my slideshow still?
You are on the slideshow still. Yeah.
Okay. I'm gonna have to change my share, I think.
Yeah.
Okay.
That's great.
Good. Perfect. So this is a snapshot of the profiler, and I'm gonna actually pop this out if I can. I'll undock it so I can make it bigger for y'all. And so again, I'm just using the 3D game kit. I just literally opened their example scene and profiled it. So this is a snapshot. And so the first thing is we can actually look at all the varying frames, and it looks just like a video out of their timeline. So as I'm moving this, if I'm scrubbing left to right with this timeline, you can see that my frame count right here is actually changing. So this is every frame of animation or every frame of gameplay that we snapped. So we can kind of scroll through. You can look at my rendering, and it's kind of interesting because you can see where the game starts, right? This is the UI when I'm at the start screen. And then it's like, oh, I hit start game. And now we're seeing that rendering start to spike as it's loading in all the objects, the characters, the enemies. But we can look frame by frame. So let's go to this little spike here. So you got 19.27 milliseconds. So that's probably the high point. Yeah, so 19.27 milliseconds right there, attributed to this. And we can now go down into this breakdown and look at all of the pieces that happened inside of this loop. So we have the player loop here taking up 14.51 seconds. We can also look under here and see the editor loop is using 1.6 milliseconds of processor time, has 3 instances running, which total 3.34. And the player loop is a total of 21 with 3 instances. So I can look right here and see that like there's quite a bit of code utilization here that's happening, right? So if I was looking to optimize my code, this might be a good start. I can also zoom into this and really dial into the milliseconds. So up here, we're looking at the frame dialed down overall. And then down here, this is that frame all put together of all the stuff happening. And we can kind of start scrolling through it and trying to figure out like what we want to look at. So looking here, we can see there's the camera renderer. We can go down here. There's post-processing happening a little bit in here. We've got some culling, which is taking 1.53 milliseconds, right? So again, culling is actually something you want. You want culling to help with your rendering times. But that is a thing you're weighing against the cost of rendering. So you do have to take that into consideration. Like, yeah, I'm going to use culling in order to, increase rendering performance. But that takes processor power too. And so that is a little bit of an average, right? You're not, just by throwing culling on, you're not going to get all these gains because you do have to spend some resources in order to make culling happen. So just something to consider there. And then as we kind of scroll through, we have our wait for present on the graphics thread and a couple other things. But really, we can find what's taking time and how long it's executing. So that's the thing I like is this timeline. My original background was in audio and video production. So for me, this is super, super handy to look at because it just looks like a Premiere timeline to me. And I can kind of see how everything's executing. And it does have that over time. And we can scroll around it here. There's a lot of stuff happening in here. I wonder if we can expand it out and zoom in. So let's scroll back and just look at this. So here's our physics stuff. So we got orange is color coded for physics. And then we can zoom in even more and kind of check out all of these different varying pieces. So right here, we can actually look at these different code pieces and look at the actual scripts that are executing. So notice like here's our enemy controller.fixed update. So this is the fixed update loop. It's got 40 instances of the enemy controller. It's using about 0.253 milliseconds. So that's pretty good, I think. But we can actually look at our individual like update loops and fixed update happening and see like, all right, these are all the scripts that are calling fixed update and what they're putting into this loop. And we can dive in so granularly to see. So for example, we have audio manager.fixed update, fixed update.audio fixed update.script run behaviors. There's so much stuff we can look at. And we're doing a lot of calculations in fixed update for this project because they're using physics to move the character around, right? So fixed update is doing a ton of work, which is why we're seeing it everywhere. So it makes sense for the code, but then we can look and say, oh, wow, we're really like, we need to bring this down. And again, those metrics are going to be set based on what your target goals are. I don't have like good numbers of like, hey, this is what you should target. It really depends on, is your game running smoothly or not on the platform you want it to run on? It's very subjective. But you can dial into all these specific pieces and then find what to fix. We can see our physics system in orange. We've got these different raycasts coming out here that are using a little bit of processing time. And honestly, this project is really well optimized, if we're being fair. But then we can also go here and turn stuff off and on in the CPU usage. So I can turn off scripts and I can turn off rendering, and maybe let's turn off like global illumination, and we can kind of turn stuff off and on and see what's really taking a bulk of the work. But again, as we'd predict, rendering is what's taking most of the work because that's what rendering does. Okay, so now that we kind of understand how to look at it, there's a couple tools here. So we can do play mode, we can do editor, or we can do an IP address. This is a little outside my scope, so I'm just going to stick to play mode and make sure record is on. So then we can jump over to Unity. Let's dock the profiler again, or just pull it. Let's see, out of the way. You know what? I'll just close you, profiler. Okay. So we have our game, The Explorer. We'll jump into play mode. I'm not sure if I'm sharing sound, so if I blow your eardrums out, I'm sorry.
That's
and then
okay.
we can go ahead and hit start right here.
I will cover my ears.
Yeah, just for safety.
Yeah.
So here's our load screen. Also, I'm assuming this video over Zoom is going to be a little choppy, so I'm sorry, but we'll just kind of run around for a second. Actually, what we should do, let me see if I can pause this. Window, analysis, profiler, and can we shrink you down, profiler? I would hope that we can see the profile working in real time as we play the game. That would be the goal here. So maybe we can do like a side-by-side dock.
Yeah.
I said side-by-side.
Probably you need to make them side by side.
Yeah.
Yeah.
Let's try that and see if we unpause the game. And then we'll turn off maximize on play. Let's see what happens. This might be a little weird control-wise, but if we hit play and record, yeah, we're going to see the profiler actually run in real time and calculate this data. See, there's the big spike as the load comes in.
Yes.
And then you see our rendering really take off.
More spikes.
And then we can just watch this go in real time. So if we want to like troubleshoot a certain segment, like maybe the game is dropping frames during combat, right? So we can go forward and find combat. Let's pick up this weapon here. And now I can attack. So let's go fight these monsters and see like if we're actually having some really bad drops during combat. All right, so let's just check that out. And we'll turn off play. And now we can just go to profile and maximize it. Let's do this. That was a very bad UI decision on my part. We can go here and scroll it up. And now we can, again, this is the session we just ran. And we can scroll through and look for those moments that we need to check out. And look for any big spikes or big issues. So again, when the UI loaded, we saw a spike here because it was bringing the UI on screen and changing out a bunch of stuff.
Yeah, probably on the while loading the initial screen, right? We have seen a couple of spikes over there.
Yep.
Yeah, right there.
So yeah, that's but again, you can do that in real time and then dial into your frame and really go in and look at what's running on your main thread, what's running on your render thread. You can look at actually the different jobs and see your different workers for jobs. And actually go through and see where things are scheduled and where things are processing, what idle time is like. You can look at your different async loads, your preloads. There's just a ton of data available to you to let you go in and really see how your game is performing and what's happening. And if you want to export stuff, you can actually go right here and you can load a binary. So maybe you have some data you're trying to profile that you just want to load in from a different session. Maybe one of your friends wants you to look over their game. They can send you some stuff and you can send them advice. Or right here, you can save your current profiling information as a binary file, and we can just call it profiled info. And now we have a data file that we can actually load into the profiler and deep dive into as well. So we can share that information around and collaborate on it too. So let's see. So that's really, let me make sure I'm sharing the right screen here. That was kind of what I wanted to plan and put together. I didn't want to spend like hours and hours diving in for a couple reasons. One, I think it's nice to see kind of how to use it and what you can apply and then have time to go practice and play with it. And then also option two is if we spend way too much time on it, you're going to start asking me really, really heavy technical questions and I won't know the answer. So that's the other scary part. So really a kind of final fun points to look at is, Unity uses batching naturally. It's going to do this. And actually, I do want to show you, can you see Unity here?
Yeah, we can see
Perfect.
it right now.
So if we go to our player settings, let's see, is that under, I always forget where player lives. It's under edit preferences, right? Or project settings. Let's pull this up here. If we go to player, so you can actually go in and change your batching settings right inside of the player. So we can actually come down and search for the different pieces. We have like our Vulkan settings. But right here, we can turn dynamic batching and static batching off and on right here in the settings if we do or do not want to use them. It's on by default. But if you think it's causing you an issue, you could turn it off. And to be clear, in order for something to be part of static batching, for starters, it does have to be marked as static in the inspector. So this transition destination is not static because it's probably moving around a lot, which means it will not be batched, right? But we can go look at our environment and we can scroll down here and look at like our cliff edges and notice all of our cliff edges are marked as static. And it makes a lot of sense because these cliff edges are drawn off in the distance and their sidewalls, they're not moving, they're fixed. And so we can definitely apply them for static batching. They're probably, I guarantee you, they're sharing materials and meeting all those needs. So you can also change your light map encoding. This is worth noting too, batching will handle light maps. So if there's a light map that's not being used, batching will actually chuck that out to save memory. So just a lot of cool things it'll do to help you. Again, optimize your code, cache stuff, clean things up. And if you can't avoid the update method, I recommend you do it. Update's super handy. When you're prototyping and just need to have something checked every frame, it's great. Fixed update's also wonderful. But if you don't need to check every frame or every physics step, then don't do it, right? Use an event, use a delegate, do something to where you're just calling it when the thing fires and needs to happen and you can control the timing. Or if you do need something to happen over time for a given period of time, use a coroutine. You have more control and you can get rid of them when you don't want them anymore. You can stop them, you can break out of them. Bake lighting whenever possible. Again, I said it once, said it before, baking is good, brownies are delicious, and baked lighting is way more optimal. And then think about it early and often. Again, it's a lot easier if you think about your code being optimal, modular, your graphics being clean, your level, if you need LODs, your LODs being ready. If your physics stuff is really optimized, if you think about that in advance and build it that way, then you're just making small tweaks to clean up your optimization versus I just built this game for a high-end gaming PC and now I need to port it to an iPhone, right? Like there's a big performance difference there you have to consider. And really, anytime I've talked to like development studios or friends that are working, those are always their horror stories about optimization. It's not like, oh, optimization is the worst. It's, oh, I had to take a game and make it play on a device that didn't have any power. But again, that's what these tools are for, to help you do that. And you will learn a ton if you have to do that. So it's a great learning experience, but it might not be the most fun. Yeah. And then again, the last thing, the profiler tools that Unity provides you are to find performance drains, to find issues, to really highlight what the problem is, and then allow you to go in, make those changes, and then come back and iterate back on top of it. And I really recommend checking out Unity's docs, check out the Learn site. Again, that optimization tips and tricks by Cristiano. If you start really looking into optimization and doing research on it, you will find that there's a lot of stuff you can do, and a lot of that information is just assumed. but you'll also find that there's probably like 10 to 20 people that are like publicly talking about it that are super, super, super smart and into it. And that information is not really well documented. So when you find videos by people like Cristiano or anyone like that, like share it on Twitter, share the love, tell everybody, because that information needs to be shared and documented, I think. And that's kind of the end of my presentation. I'm happy to answer any questions to the best of my ability. And then if you want to hang out on social media with me, that's my Twitter handle. I mostly just yell about like fighting games, pizza, and Unity development. So
that's great. Thank you very much, Thomas. Actually, I have a question of my own. I'm really curious about when you are starting a project, and a brand new one. I mean, what is your approach in general with consideration to optimization, keeping that in mind, of course?
So I think for me, the first thing I do when I'm building something is like, what's my target platform? A lot of my dev stuff is really like prototype things for like education. So like right now, the project I'm working on is called Thrashy Trashy Pandas. And it was a game that was literally mad-libbed during the Create with Code session. And now I'm like, well, I've got to finish it because I told them I'd upload a playable build form, right? So I already know that we're working with WebGL. So I know like that's my end platform. So the big thing for me is like, I focus when I'm coding on caching variables is the big thing I always try to do, caching components. And then the other thing I always try to do early on is if I write something in the update method and make sure it works, the first thing I do after that's done is I pull it out into its own function and figure out where I can call it. Like that's the next step for me. So if I'm like, oh, I just need to get this working and I write it in update, the next step is like, say it's move player or something. The next thing I do is build like a function called move player and move all that code into it so that I have that available to call with events or whatever I need to do. So there's that. And then I haven't really had the opportunity to work with like a lot of super high-end artists lately. But when we were building for Pluralsight, when we were working on Swords and Shovels, which is a basically full-scale tutorial on building a game, it starts with like essentials and then it goes through coding everything.
Yeah, by the way, that was a great tutorial.
Thank you.
Keeping it
so
in
good.
the archive. Yeah, that's great.
I'm hoping they let us update it because Josh and I were just talking this morning about how we'd love to like completely rebuild it and like do it with Unity 2020. But the big thing there was like when we were working with the artists, there was a lot of like, hey, like let's make this as clean as possible. And even then, we didn't hit the mark. I don't think we actually ended up when working with some of the other artists. We ended up using, was it Super LOD? I think was the tool we used to go through and just like absolutely crunch it down to make it more performant. But I wish we would have thought of performance in the models and the geometry. We were so focused on, we want this to look beautiful. We didn't, and we're only building this small slice. We didn't stop to think like, hey, we need to make this run really, really well. And as an example, we were actually demoing it at GDC 4 years ago, I think. And it was running at like 35 frames a second at GDC. And granted, like we could just, our pitch was like, well, it's for education and look how pretty it is, even though it runs like garbage on this laptop. But so like, that's a big thing I wish we would have really considered was like, we have way too much geometry and this is way too pretty.
Ladies and gentlemen, that's a big confession by Thomas Winkley.
Yeah, that was a rough one. But at the same time, like it taught us a ton of like, okay, next time, like let's have beautiful assets, but make sure they're clean. So
yeah. That was a really great tutorial with lots of things to learn for Unity community, I think. And fingers crossed, a nice update for 2020 would be great, actually. Yeah, we would love to see that, Thomas. We are hoping to get one from you and Josh and Pluralsight, of course. We are looking for that. Okay. All right, guys. Do we have any questions, Ece?
No, actually, we don't have any questions
from the channel. Okay.
Thank you, Thomas.
I think everything has been understood very well. We would like to thank Thomas. Yeah, thank you very much. Yeah, this was a great opportunity for us to learn more about how to make better use of Unity Profiler by trying to create more performant and optimized projects in Unity. And I hope we can have you back sometime later with another important Unity topic. Ladies and gentlemen, Thomas Winkley was our guest speaker today. Before you all leave, I want to remind you to stay tuned because we are going to have another experienced developer next week with us. He will talk about one of the most requested topics by you, addressables, actually. Event announcements will be published very soon via our social media channels. So please follow us if you would like to get notified as soon as the next event's details are available. Thank you, everybody. See you next week, hopefully. Thank you again, Thomas. I would like to see you again with us, maybe in the couple of next weeks. I don't know. You have a very tight schedule, I know. But it was a great pleasure to have you with us today. Thank you so much.
Thank you, Thomas. Have a great one.
Bye.
Bye-bye.
Bye-bye.